Now, in this present lecture, so we study the DC motors, piezoelectric actuators, and shape memory alloys. The DC motors or direct current motors are used in a large number of mechatronic designs because of the high torque speed characteristics available with the different electrical configurations. DC motors can the speeds can be smoothly controlled and they are reversible in most cases. Since DC motors have a high ratio of torque to rotor inertia, they can respond quickly. DC motors are based on the principle that when a current carrying conductor is placed in a magnetic field, it experiences forces. Now, the figure shows very simple form of DC motor. The single coil is located between opposite poles of the simplest magnet. The magnetic field is produced by the permanent magnet or electromagnet and it forms the stator. The coil of wire acts as the rotor. In conventional DC motors, several coils of wires are mounted in the slots on a cylinder of magnetic material called armature. The armature is mounted on the bearing and it is free to rotate. It is connected to the source of DC current through which mounted on the shaft and it is called commutator. When the electric current flows through the armature, conductors placed in the magnet field experiences a force which causes the armature to rotate. As the armature rotates, the commutator is reversed. The current in each coil and it moves between the fields. As the commutator are split, the current directions through coil reverses and each time and thus the rotational torque is present all the time and the coil continues to rotate. Based on how the stator magnetic fields are created, DC motors are classified into four categories such as permanent magnet, shunt wound, series wound, compound wound, and separate wound. Now, the permanent magnet motors, the stator fields are provided by the permanent magnets shown in the figure, which require no external power source. This type of motor is lighter and smaller than the equivalent DC motors because of the field strength of the permanent magnet is high. These motors are easily reversed by switching the direction of the applied voltage because the current and the field change direction only in the rotor. Next one is the series wound. The series wound motors have armature and the field windings connected in a series. So the armature and the field currents are equal. Series motors exhibit a very high starting torque. The shunt motors have armature in the windings connected in parallel direction. The total load current is the sum of armature and the field currents. Now, the compound wound. The compound wound DC motors is basically a combination of shunt wound and series wound configurations, which is the result of combined characteristics of both shunt and series motors. Now, the piezoelectric actuators. The piezoelectric actuators achieve displacement just wait. Okay. Now in this you can see the piezoelectric actuators. Piezoelectric ceramic materials is used in the piezoelectric actuators generate electrical energy when it is subjected to mechanical energy and generates mechanical energy when it is subjected to electrical energy. That is piezoelectric effect. The piezoelectric actuator is a device that makes use of the inverse piezoelectric effect. For example, when a voltage of about 1000 volt is applied to a piezoelectric ceramic with a thickness of 1 mm, the plate with a thickness of 1 mm, a displacement of about 1 micrometer is obtained due to the inverse piezoelectric effect. However, at this in the practice insufficient. This practice is insufficient because only a small displacement can be obtained with the high drive voltage. The piezoelectric actuators are structurally processed in order to obtain a large displacement from the lower drive voltage, and the process has thus been put to practical use. So, in order to reduce the voltage of piezoelectric actuators, it is necessary to reduce the thickness of the ceramic plate. Now, when an inverse voltage is applied to two piezoelectric plates, warp deformation is a consequence. The arrangement can offer a relatively large displacements, but the force is not large. This device is implemented in a cantilever construction for use in positioning mechanisms, etc. And the driver voltage is usually in some hundreds of volts. Now, about shape memory alloys. That the materials that remember their original shape and return to it when heated, even if permanent residual deformation was introduced below a certain temperature, is called shape memory alloy. The original shape can set by heat treatment. The shape memory alloy crystallographic structure changes between two phases. The low temperature phase Nithinol is shape memory alloy, which is an alloy of nickel and titanium. Shape memory alloy is used for such things as actuators, which are materials that change shape, stiffness, position, natural frequency, and other mechanical characteristics in response to temperature. The shape memory alloys actuators are made as wire, spring, ribbon shape. It is able to produce extreme forces for the viewpoint of the volume to force ratio on the way shape memory alloys elements can only provide force displacement in one direction. For example, a wire that compresses when heated and does not expand without external force when the alloy cools down. This is the disadvantage of one-way shape memory alloys actuators. The bias mechanism must be used if the actuator has to be returned to the original shape after the heating phase. The gravitational bias force shown in the figure. It is the simplest way. If possible, a load force can be used as bias force. The spring bias force increases the weight of the actuator and the mechanical designs becomes more complex. It must be noted that output forces decreases because of the force of the bias mechanism opposes the force of the shape memory alloys. Unorganic arrangement of two one-way shape memory alloy actuators. Two-way shape memory alloy effect also exists, and there is no need to solve bias mechanisms in case of two-way arrangement of two one-way shape memory actuators. Consequently, the displacement is as high as in one-way shape memory actuators. Thank you.